So when we talk about open meet me rooms, we're really looking at a way to allow you to do software control of all the physical interconnects within a multi-tenant data center through an open API. In our case, it's a REST API, so that customers can programmatically control all the connections in these remote facilities. So what we're really solving is this problem of today a data center could have hundreds of thousands of cables that are managed through manual processes, takes technicians, takes a real slow, typically can take days to do reconfiguration of those connections. And because the entry is manual, there's a lot of tendency to have errors during that process. So you could look at, well, what if you take a robot and automate this? And it turns out that isn't so simple. You could imagine putting a robot in front of one of these frames and trying to reconfigure thousands of cables. There's some real challenges. The optical interconnects can easily tangle, and that's really fundamentally one of the biggest problems. Also, optical fiber is delicate. You can't bend it excessively, so you can't just go and pull a connection and plug it in somewhere. That'll start leading to performance degradation. Also, robots are typically quite large to be able to fit within a high-density cross-connect. And it needs to be very reliable, much more so than, say, an optical switch. If you lose power to such a system, all the connections would need to be preserved, or it's typically called latching. So what we looked at Tellison is there a mathematical algorithm in which we can take a robot and have it arbitrarily configure these interconnects and really solve this problem? So it turns out there is, and it's based on a real unique routing algorithm that's fundamentally based on the theory of knots and braids, which has been used in string theory and DNA folding and unfolding. So combining that with robotics and also performance monitoring adds a real intelligent way to manage these connections. It's also a purely all-fiber design, and what's important there is there's really no way to beat an optical fiber connection in terms of loss and performance. So it really enables it to have unsurpassable performance and future-proof. So this shows the inside of the actual system. We call it a network topology manager. And let's see if the animation works here. Okay, so this shows the inside. That's 1,000 fibers. This is one fiber that's being moved by the robot. And on the far right, that's actually the routing algorithm that is calculated. It's a lot like a puzzle, like a Rubik's Cube, where you would determine what the end state would be and then determine all the moves that have to be performed so that fiber, the yellow fiber, can move through the surrounding 1,000 without tangling. So when you send it a command through, say, the REST API, it'll then calculate that and reconfigure the fibers to any state. It's totally arbitrary, so for 1,000 fibers, you can have 1,000 factorial states. It's non-blocking. So how this ties into mathematics is the fibers or strands. If you'd have blocking, that would really be a knot, where two fibers would start tangling with one another. And the complete set of fibers forms a braid. And that's where we really leverage the mathematics of knots and braids. So this is the system. It's implemented in a 7-foot rack. And it has an operating system which has the algorithm. It's a Linux-based system. And the REST API allows easy programmatic control of it. An orchestrator allows multiple units. There could be 100 of these in a large data center. It allows them to all be controlled, so it appears to be one switch fabric. Monitoring apps include, for example, an OTDR or an optical power monitor. AI optimization apps, I'll talk a little bit later about some work AT&T has done to optimize the network to achieve higher utilization with this type of programmability. And the topic of this presentation is really automated Meet Me Room app, where this becomes the Meet Me Room in a data center. And so now you have an open API where instead of sending people out, you would just through software access through the API, and you can automate record keeping, troubleshooting, reconfiguration. It obviously speeds up now, the reconfiguration. It can be done in a matter of minutes. It is a physical robot, so it does take minutes to perform a reconfiguration, but typically that could take days. It speeds up DevOps, migration, service restoration. And for operations folks, some of the key things are that dreaded call in the middle of the night now can be eliminated because this system can programmatically recover based on predefined scenarios and scripting. So the NTM is really at the center of a lot of different tools. This is a lot like you take an industrial robot. It's not a lot of use until you put all the tools like a drill, a welder, a screwdriver. So in this case, those tools include an OTDR, an optical power meter, packet analyzers can be added, D-packet inspectors, and then apps like an automated Meet Me Room app that builds the functionality around the NTM and enables use cases. So the NTM enables optical monitoring to be really embedded now in the network and distributed. So anytime, anywhere in the network, you can do monitoring. It can be scheduled in the evening, doesn't need people to do it. And again, the probes are various traditional optical measurement devices. So the use case we want to focus on is the automated Meet Me Room use case. And you're probably all aware there's this long-term trend for enterprises to outsource data centers to the cloud. And typically, the enterprises want to own the equipment and just put them in a secure building. So the multi-tenants allow that to be done. And it really drives the need for a Meet Me Room to connect the enterprise to all of the carriers to access the services. And Equinix, for example, they've forecasted a 48% annual growth rate of the interconnect bandwidth. So it's really growing very rapidly. And these connections are really the key thing in the multi-tenant. So for example, if you have this NTM in between two or more customer cages, it can now manage the connections between the customers as well as even the connections within a customer cage. So it's a new premium connection service where now instead of calling Equinix, requesting a connection or requesting smart hands, the customer can log on to a portal directly to the NTM and perform those functions. So it serves as a marketplace between enterprises and service providers to connect and turn up new services. So it's really something that we're finding is implementable both in greenfield and brownfield, where in the brownfield center, this can be an add-on service to the existing manual Meet Me Room. So this is a sequence of slides kind of showing how this marketplace works. So the enterprise service providers would all have their accounts in our platform, and the enterprise can make a request, and the service provider then would say, I'll provide on my port number 10 gig service or 100 gig service. And once the handshake is complete between the enterprise and the service provider, the NTM would automatically execute the connection. So now this is done in a matter of minutes. It gets rid of all the LOAs, all the paperwork that can slow that process down. And this can be scheduled to happen at any time. So the other use case would be an enterprise may have a lot of connections in their cage where rather than having smart hands go out and do a reconfiguration, they can now have this system manage the connections within their cage. Because it's 1,000 ports typically, it can be shared among multiple customers now for very cost-effective switching. This shows the architecture of the application. Depending on the particular end users, in some cases, it would be through the Telesynth front end, basically a web GUI, or through the Open REST API, it can be connected up to any customer clients, for example, their own web portal. And the back end includes the management of customer registration, the cross-connect request, process flow, and also access control, accounting, and logging. Obviously, this keeps track of all the records now automatically, so there's no human entry. The back end then connects to the orchestrator, which if you have multiple NTMs in a facility, it would actually make that all transparent to the end user. You wouldn't need to say NTM1 does this, NTM2 does this. It would look at the complete connection and the fabric of the NTMs and create a simple connection, isolating the user from all that complexity. So we believe that ultimately automation will become ubiquitous in these meet me rooms. The initial value proposition is faster service delivery, minutes versus days, increased revenue generation through new services, including the ability now to, an enterprise could switch in a packet analyzer rather than own their own. It could be shared among all the customers or clients of a multi-tenant. And obviously reduced OpEx, doing things instantly without humans touching. That improves ultimately the customer satisfaction and competitiveness of multi-tenants. And that's where we really believe this will drive the deployment, because it'll be a much higher level of service now that a multi-tenant can offer to enterprises and service providers. A couple example value propositions. This is an interesting paper from Microsoft, which didn't actually talk about automation of the physical layer, but it points out that when they looked at trouble tickets leading to packet corruption in their Azure data centers, it's surprising, the number one cause of problems was connector contamination. The number two was damaged or bent fiber. So really pretty mundane things that most people tend to not be too focused on. So it really shows that the manual processes, they can degrade the compute efficiency dramatically. And so how the NTM can solve that is it has automated cleaning of the connector, so it gets rid of all the variability of making connections. It also automates the monitoring and performance, so when creating a connection, it can actually go and validate that, say through an OTDR. This is an example of the loss histogram of the system. So it's really basically a fiber with two connectors, so it's like a manual patch panel. But unlike a manual patch panel, you don't have the human variability, adding loss variation. So the loss is typically about 1/4 dB. So the interesting thing is there's a lot of focus at this show and many others on higher speed pluggables and the cost of them. And one strategy of reducing the cost is to reduce the link loss budget or the power of the laser. So the NTM, because it can provide these very low consistent connections, it helps to support that reduced link loss budget, enabling data centers to achieve, say, a physical plant with maybe 3 dB of loss versus 5 dB of loss. Another interesting use case is based on an AT&T paper where they looked at combining machine learning and programmability of the physical topology of their long-haul network. This was back late last year. And they found that by being able to program the interconnections with they call it a dynamic fiber cross-connect, they could achieve 34% cost savings in their global network. So very significant CapEx reductions by being able to be intelligent about how spares are shared, as well as doing load balancing. This paper is really looking at connections between routers and the Sienna line gear. So they found that their manual processes today prevent really optimizing the utilization. They don't want to have people go out and make changes because people make mistakes. So it was quite surprising. Even Dilbert has expertise in network operations. This is one of their actual cartoons mentioning basically the same problem. Get rid of humans, that cause problems plugging in cables, contaminating the network, and causing performance issues. So it's clearly a well-known problem, and we think automation is the ideal way to solve this. Thank you.